Let's explore async and await in React, a modern JavaScript syntax that greatly simplifies handling asynchronous operations. It provides a clean and readable way to make API calls and fetch data within your React components, making your code easier to understand and maintain. Async and await are syntactic sugar over promises. This means they are built on top of promises, but provide a more straightforward and synchronous-looking way to write asynchronous code. Async and await offer cleaner syntax, improved readability, and easier error handling compared to traditional promise chains. Here's how you might fetch user data using traditional promises with the then and catch methods. First, we call the fetch function with the API endpoint. Then, we use then to handle the response, converting it to JSON. Another then processes the JSON data, and finally catch handles any errors. Promise chains like these can quickly become complex and difficult to read, especially when dealing with multiple asynchronous operations. Now let's see the equivalent using async and await. We declare an async function fetch user data. Inside, we use a try-catch block for error handling. Within the try block, we await the fetch call to the API endpoint. Then we await the response to convert it to JSON. Finally, we call setUsers with the data. The catch block handles any errors. Async and await provide a linear, synchronous-looking structure that's much easier to understand and follow. Here's a basic example of an async function used within a React component. We define a user profile component that uses the useState hook to manage user data. The loadUser function is declared as async, taking a user ID as input. Inside loadUser, we await the fetch call to retrieve user data from an API endpoint, and then await the response converted to JSON. Finally, we update the user state with the fetched user data. It's a good practice to define async functions directly inside your components for making API calls, keeping your logic self-contained. Here's how to use async functions with the useEffect hook. Because useEffect cannot directly accept an async function, we define an inner async function called fetchData. Inside fetchData, we use try-catch to handle errors. We await the fetch call to get product data, then await the JSON conversion, and update the product state. Any errors are caught and set to the error state. Finally, we call fetchData inside useEffect. Remember, the useEffect callback itself cannot be async. Therefore, you need to create an inner async function and then call it. Error handling is crucial when working with asynchronous operations. Here's how to use try-catch blocks effectively. We define an async function called handleSubmit that takes form data as input. We start by setting a loading state to true. Inside the try block, we await the fetch call to submit the form data to an API endpoint. We also await the response to convert it to JSON. If successful, we set a success state to true. In the catch block, we handle any errors and set an error state. The finally block ensures that the loading state is always set to false, regardless of success or failure. Try-catch blocks provide clean and reliable error handling for your asynchronous operations. Let's cover some best practices for using async and await in React. Always use try-catch blocks to handle errors gracefully and prevent app crashes. Add loading states to provide visual feedback to users during asynchronous operations. Implement cleanup on unmount to cancel ongoing requests when a component unmounts, preventing memory leaks. And handle network failures by providing fallbacks for offline scenarios to ensure a smooth user experience, even with connectivity issues. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.